In this next unit, we're going to learn about some counting principles, some different ways to count the number of ways that things can be done. Our first principle is called the inclusion-exclusion principle, which is defined as the number in A union B, which means symbolized by the letter U, but it means or. So the number in A or in B will always equal the number in A plus the number in B minus the number in the intersection of A and B. And the intersection means the same as and. It can also be shown in a Venn diagram with overlapping sets where this region is the intersection of the two. Oops, should be an upside down U. And anything on the inside here in any of these three sections would be the union of A and B. So an example of when you would use this principle. Of the 540 seniors at Central High School, 335 take math, 287 take science, and 220 are taking both math and science. How many are taking neither? So therefore, using the principle, we could say that the number taking math or science would equal the number taking math plus the number taking science minus the number taking both math and science. So now plugging in, we've got 335 people taking math. We've got 287 taking science. And then if there's 220 taking both math and science, we would need to subtract that total off, because otherwise we would be counting them twice. If we do this math, we're going to have 335 plus 287 is 622 minus the 220 would be 402. So that would be the union of these 540 seniors. 402 of them would be taking a math or a science class. Therefore, answering the question, how many are taking neither? That would be the other. If we take 540 minus the 402, that would be the other 138 would be taking neither. Now we could set this problem up using a Venn diagram also. My Venn diagram, I'd make a box. And then I'd have my overlapping circles, which I would call math and science. My union here, I have 540 seniors. So I have 4 sections in this Venn diagram. All 4 of them must add up to be 540. It says that 220 are taking both. That would go in the middle there, the overlapping section. Since there's 335 taking math, in this area there'd be 115. That's the 335 minus the 220. And in this section, taking only science and not math would be the 287 minus the 220, which would be 67. If we now add these 4 numbers up, that is the union of this set. That is or math or science. That adds up to 402. And therefore, on the outside here, we'd have 138. And that's the number that are taking neither math nor science. The next principle we're going to talk about is the multiplication counting principle. Really a very simple principle which says if an action can be performed in n sub 1 ways, and for each of these another action can be performed in n sub 2 ways, then the two actions can be performed in n sub 1 times n sub 2 ways. So when we have the word and, we are going to multiply. Okay, so a couple examples here. If you have 4 sweaters and 2 pairs of jeans, how many sweater jean outfits can you make? So in this situation, one of the actions is that the person has to choose a sweater. They could do it 4 ways. The next action is then they need to pick out the pair of jeans to wear, which they could do 2 ways. And then we're going to multiply these together. So there would be a total of 8 different sweater outfits. You can do this with kind of a tree diagram here. If I call my sweaters A, B, C, and D, I have to choose a sweater. And then for each of these sweaters, I could choose jean 1 or jean 2 for each of these. And as you can see, there would be 8 possible situations here. Second example says, in how many ways can 8 people line up in a cafeteria line? So in this case, the actions would be putting a person in each position in this line. If I'm going to place a person in the first spot in the line, I have 8 choices for that person. Once that person is decided on or chosen, now I've got 7 choices for the second person, then 6, then 5, then 4, 3, 2, and 1. And I would multiply all these together. When I do this, this is the same as 8 factorial, which is an exclamation point, 8 factorial. To do this on your calculator, you're going to go to Math. You can choose Probability. And then the factorial one is, I believe, in line 4. So you'd put the 8 in, and then you would use the factorial button there. Should come out to be a grand total of 40,320 different ways that people could line up in a cafeteria line.